Hi, good day everyone. So today we're going to learn on the tips on how to remember the matrix format of reflection. Now, if you are good at memorization, this is a table where for matrices of reflection, if you have reflection in the y-axis, it would be negative 1, 0, 0, 1. This is how it would look, what it would look like if it is a reflection on your y-axis. Zoom out, right. Reflection on your y-axis. If it is a reflection on the x-axis, which is located in the pink, that is denoted by the pink, it is 1, 0, 0, minus 1. It is reflection on the y is equals to x, it will be 0, 1, 1, 0. And if it is a reflection in the y is equals to negative 1, it's 0, negative 1, negative 1, 0. Now, if you are not good at memorizing, the matrix that we have to multiply to get that object, to get that image, right? We are going to learn the tip. Now, the tip to remember in this is first we have a Cartesian plane. Now, in a Cartesian plane, the few things that you need to remember is, well, this is general knowledge. This is your y-axis, where x is equals to 0. And this is your x-axis, where y axis where x is equals to 0. Now, if you realize something, we only have for reflection, the transmission of reflection, we only have ones and zeros, right? So if let's just say this is the location, the coordinate of this would be, because it's on your y-axis, x is 0 and y is 1. Right here, x would be 1 and y would be 0. Here would be x is negative 1. So 0, negative 1. And this one here would be x is negative 1, y is 0. Right? Then the next thing that you have to remember is you're going to have to remember it's going in this direction. Now, we have, if you remember, let's start with y is equals to x. The equation of the line for y is equals to x would be a line that looks like this, right? Now, what we will have to remember is this first quadrant here, you'll put y is equals to x, and opposite that, that's this location, y is equals to negative x. On top here would be your y-axis, and here would be your x-axis. So once you remember this, it is going to be easier to remember. So on your y-axis, now when we are describing or when we are denotating the matrix to be multiplied, you have your x values first and then your y values. Right? So for y is equals to x, which is this quadrant, you have 0, 1, and then that's your x values, and then 1, 0. Now remember, you have to go to that location. That is why 0 is first, and then 1, and then 1, and then 0. Right? Then for your x-axis, we're going from here and going to this location. So your x first, which is 1, 0, 0, minus 1. For your y is equals to negative x, we're going from here to here. We have your x values first, which is 0, negative 1, and then negative 1, 0. And then the last one, which is on your y-axis, you're going from here to here. That is your x's first, negative 1, 0, and then y, 0, 1. And that is how you can remember reflection of reflection, reflection in the matrices format. So again, let's just repeat. Very quick summary. We know that your x-axis and y-axis on the upward part of your y-axis we have 0, 1. On the right hand side of your x-axis is 1, 0. Below your y-axis is 0, -1. And on the left hand side of your x-axis is -0. You are going in this direction, in a clockwise direction. Alright? You remember the equation of the line for y is equals to x is that. That would give you a easy way to remember that your first quadrant is y is equals to x. Then we have the opposite of y is equals to x is y is equals to -x. The one on top here is y-axis, and then the one at the bottom here is your x-axis. Right? Then, if you want the matrix that you have to multiply to represent a certain reflection, we have the x values and then your y values. So it's from 0, 1, 0, 1, 1, 0. Then for y is equals, on your x-axis, 1, 0, 0, -1. This one, which is opposite y is equals to x, that is why it is y is equals to -x. 0, -1, -1, 0. And then for your y-axis, -1, 0, 0, 1. And that is how you would know. Now, very quickly, let's go to the next page. The formula that you have to remember, right, is the transformation for the transformation of both rotation and for both rotation slash reflection. The formula would be the matrix, the 2 by 2 matrix that represents whatever transformation, the matrix transformation, multiply by your object. For example, x on top, y at the bottom, whatever the coordinate is, x on top, y at the bottom would give you your image of x image and your y image. And that is how you would find out the coordinates of your image given once you know the transformation, your matrix transformation, and the coordinate of your object.